Hello, Dr. Jones back with you again. And for this video, I want to take a look at how personality trait researchers can take something as abstract as personality and use math to help us understand it, also known as psychometric research. And really, there's two things you need to know for this course, and that is factor analysis and empirically derived. So for factor analysis, this is a clever thing that researchers did is they started looking at all the different traits that can be used to describe people, and they started going through the dictionary. They found that there were thousands upon thousands of traits, of adjectives used to describe people's personality traits. So they said, how do we boil down these thousands of traits into a manageable number? And if you recall back in our research methods unit, when we looked at statistics, we looked at correlations. And that's what they did. They used correlations. So let's review for a second, what is a correlation? A correlation is simply a relationship between two variables. Again, we don't know what causes that relationship. We just know that the presence of one allows us to predict the presence of the other. Well, this is perfect to use for traits. So what they did is they assessed a number of different people on a number of different traits, and then they looked to see, did any of those personality traits correlate strongly with other traits? And then if they did, they could eliminate some of them. So I used excitement up here as an example. And actually, let's go to a bigger version of this. So if we go to excitement as our example, they found that excitement could correlate with impulsivity. All right, so if excitement is correlated with impulsivity, which one do we pick? Well, it turns out excitement is also correlated with a lot of other traits as well. So when it's correlated with those other traits, excitement becomes the basic trait, and then we don't need to test for these other ones. Why don't we need to test for them? Well, because the presence of one allows us to predict the presence of the other. So if you scored high in excitement, we would know that you would likely score high in impulsivity. So we don't need to test you for impulsivity because it's already correlated to it. All right, so that's factor analysis. All right. The second thing you need to know about, you don't need to know how to do it, but just know about what it is. It's called empirically derived. And this one is most prevalent in the MMPI, the Minnesota Multiphasic Personality Inventory. And what they do is they give a number of participants that they know to be from a certain category. In this instance, for the MMPI, it would be dealing with mental health. So they would have people who are, quote, normal and those who are abnormal. All right, so you would have people who are healthy mentally and those who might have a mental illness of some type. And then they would give them a series of statements to respond to. Could be questions, and the MMPI tends to be statements that they would use a Likert scale to either strongly agree, strongly disagree, or be neutral on. And then what they do is they see how if a majority or a large number of the one group, let's say the normal group, answers one question one way or one statement one way, but then a large percentage of the, say, clinically depressed group responds to a question differently, then in the future, when they give that personality inventory, if people answer similar to the depressed patients, they can use that as an indicator that that person might be depressed, right? So they're really looking at differences between groups' responses and using that to predict future participants' behaviors, personalities, as I said, mental illnesses, among other things, to determine if they fall in that category. All right, so those are two different ways that personality trait researchers use math to help them be able to take this abstract idea of personality and use some psychometrics to help be able to describe it.